Welcome YouTubers. Back again on this. I got this E682 out of storage and getting ready to work on Christmas. I know I did a video in the spring that was pretty long. You can go look at it in my comments below, and it was a brief introduction with some simple setup on how to do some simple strings. In this video I'm going to block out a little expansion to that. I've got about 700 something pixels, and how to set up the E682 with multiple power supplies and how to wire it up, so this is more of a detailed video on the exact settings, so I'll go in a little more detail because I think I had some questions before from some other people, and I just want to get that straightened up a little bit. So let's get into it. So the first thing that I wired up here, it's sort of a mini megatree. Megatree is one of those functions in Vixen that sort of, you have a common point up here, and these will splay out like a Christmas tree in the various radial directions, sort of give an effect. It's a nice effect on the thing. It's a nice setup, pretty standard setup. So what I've done here is I have these, again, straight wire up at the top. I don't know if you can see that real well. I've gone up, they're 50 length string each, and I've gone up 25, and then I've sort of just put two clips there and then come back down the other half of the string for another 25. So one of the strings is an up and a down, and then I've done, let's see, 6 total strings. So here's the second one going up and then down, and a third one going up and down. That's the left side. That's 150 pixels total, 3 strings of 50, sort of 6 strings up and down at 25. So it's going in a zigzag pattern, up, down, up, down, up, down. And I've done the same thing again on the right hand side of this tree. Again, three strings of 50 and an up, sort of joined right there. So up 25, loops over, comes back down. And I repeated, so that's 300 total pixels, 6 strings of 50. As far as the hookup, I'll get in a little detailed chart on the hookup just to show you that. So this is an example. I don't have a star on it yet, and I'll probably do some other stuff. And I mirrored that tree again. Exact same configuration over here. I'm going to plant these in the ground and use some tent space out in the yard. Right now I'm in my lab, which is my man cave. Right now, for this week at least, it's my demo lab, trying to get these up. And I've just run the wires against some cardboard just to help me get it wired up here. I'll rewire it out in the yard to get a little longer distance. I just wanted to get the functionality because I have problems, just like everybody has problems setting up these Vixen controllers in the E682. I've also got 4 rings, circles, and each circle is on a hula hoop basically, and I've got 34 pixels per hula hoop, and they go around in a circle. Then it goes to the next one, then it goes to the next one, then it goes to the next one. They're going to be side by side, I think, in the yard. And so I'll be able to do some half hoops or circles, or if you ever look at that 4 circle side by side, I'll be able to do various effects. Should look pretty neat. So let me get a little schematic going here. Let me get the drawing out. So just to reiterate what I did for the mega trees, it's up, down, 1 string. I'm going to join them together on the data line down here. Then up, down, join the data string, up, down. And that's the left side, and that's going to be fed to the data back to 4.1 or 3.1 for my 2 trees. I got 25 pixels, so 1 through 25, and then 26 starts up here. So it's sort of a zigzag pattern. And the same thing happens on the left side. I happen to use data 4.4-2 and 3-2. That comes in there and goes up, down, up, down, up, down. So that's the physical. It's 300 pixels total, which is going to be 900 connections when you multiply it by 3. That's what you need to do for the red, green, and blue. I explained that a lot in the first video. Logistically, as an element in Vixen, your mega trees or your matrices typically want to run, I've got a 12 by 25 pixel, so 12 strings times 25 in length. That's my mega tree in this case. And they always want to start in the lower left and go up, and then go to the next string and go up, and go next string and go up. So they're not zigzag. They're up, 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 and they continue to go across in a right-hand pattern. So the last ones are 276 to 300. So it's 1 to 25, 26 to 50. So you see how it's going up and going that way. That's how it prefers to look at element of a megatree in Vixen. So I've got a delta between these two. So this isn't a zigzag pattern. This is sort of in a straight pattern or matrix pattern. So there's a couple different ways that you can get these zigzag to line up with the elements. You can either manually patch each string of 25 and then reverse manually patch. So you have to do that for each string of each tree. So 12 times the number of trees you have. For me it's 2, it's 24. It's kind of a pain in the butt. But if you ever run short in space, I'm going to talk about space a little bit further on in this video. But that's one way to do it, is to manually do it. It takes a little bit of time. Every time you want to patch a controller, you got to do each those 12 strings individually and reverse them and select them. Kind of pain in the butt, but able to be doing it. You can save you some space. But if you have the luxury of overhead, in other words, groups that you can zigzag in an identical pattern, then you can do that right on the E682 card. And so I'm going to do that in this video. I'll show you a little later. But I'll zigzag every 25, and that'll correct. So when it goes to 26, 50 will be 26, and 49 will be 27, and then 26 will be 50, and it's going to line up like that pattern. You just do it in the hardware on the 682 card. So that's kind of nice, as long, you know, that entire group will be zigzagged in the quantity that you want to do. So it's 150 pixels over here, 150 pixels over here. I got 2 trees, and I went through that. So the circles, even though I've got it lined up so they're top dead center in this video, that's where I hooked them up at. I'm gonna want to start at 1 in the 9 o'clock position, and when I lay them out there in the yard, and they'll go around in a counterclockwise for 34 total. And element wise in Vixen, I've got 2 different patches to the same thing. So I've got the whole circle, so I can light up the whole circle at once or chase around the whole circle. But I'm also going to do top halves and bottom halves. I'm going to break it into 2 sub-elements in case I want to do like an arch that leaps like this, or I can do down and around and just go like in crazy patterns, or I can just bridge it up. There's a lot of things I can do. So I'm going to do 1 through 17 at the top. I'm going to do a bottom half 18 to 34. So that's the element setup and the physical setups that I've got in this configuration. It's important to know the physical and to design those ahead of time, of course, to keep the trees identical. That helps too as I go forward into the setup and the parameters, and that will make sense to you, okay? So the next important concept is the connector, controller connector map. I call it the position line. So in multicast mode on these things, you only have 7 universes. If you go to unicast, you can expand those number of universes, but the standard setup is multicast. And so I've kind of positioned out a timeline or a position line here. So it goes to universe 1, 2, 3, 4, 5, 6, 7. Each universe has 1 through 510. So that's what you're seeing over here. So 1 is 500 through 10, 2 is 1 through 510, 3 is 1 through 510, and so on and so forth up to 7. And that's what's available to you in the standard connection. So you'll see that when you do your connections. Of course, each pixel requires 3 connections. But I also drew in the absolute. This is how I recommend setting up your controller, just to keep your sanity logic. So in absolute positions on the controller, when you go into Vixen, you know, universe 1.1 will be 1, and then it'll go up to 510. Then universe 2.1, and that's how the E682 likes to think of it, will be absolute position 511 up to 1020, and then 3 is 1021 to 1530. 4 is 1531 to 2040, 5 is 2041 to 2550, 6 is 2551 to 3060, and lastly 7 is 3061 to 3570. So if you have more than, you know, if you set it up with more than 3570 positions, you'll have these standard 7 universes. It's good to plot this out this kind of way, just to get yourself oriented and keep these numbers. You can change these numbers, but I recommend just keeping these universes the same and having those 3570 absolute positions. Then what you'll need to, when you get tight on space, or if you just want to conceptually think of this, a tree for me is 300 pixels. Remember, that was my pixel tree, which is 900 points. So what happens if I start tree A at universe 1, position 1, it takes up the entire 510 positions of universe 1, and it spills over the balance which is another 390 positions of Universe 2. So it fills most of Universe 2 up to 390. So that makes the total 500 points. So when you plot that out, you're like, okay, that's what my first tree is. The second tree I started at Universe 3. You can't start at Universe 2 because it's already consumed most of that. You could start at that position 391, and it would be not have a little. There's a 120 point buffer right in there that's unused right now. But I started my tree for convenience, tree B, my second tree, in Universe 3, position 1, which is absolute position 1021. You're going to need that number to map it into the Vixen controller section. And that B takes up 900 points, just like the other tree did. So it takes up the entire Universe 3 and spills into Universe 4 automatically, and takes up most of Universe 4, 390 positions of Universe 4, identical. So now 1, 2, 3, and 4 are mostly consumed. There's a little bit of buffer, but not a big deal. And then I've also got the circles. The circles were 34 times 4, which is 136 pixels. Multiply that out, that's going to take 408 points. I have them in a consecutive string. Just like these trees, I have 150 in a string, 150 in the string, so pixel-wise. So it's going to take up 408 points. So I put that on Universe 5, position 1, just for my convenience, because I have space. And it takes up 408 points, so it doesn't take up the whole universe even, because it's 510 points in the universe. So that's all I've got. And universes, there's a little bit of a buffer, so 102 points of buffer in that. And then there's Universe 6 and 7 are completely wide open for me right now in my current configuration. So that's another. So I could fix in more pixels as long as things lined up okay. If I ever really got tight on space, I could shift. Like I said, I could shift this tree over 120 and take that buffer out, and then that would move this over 120, which means I could move this over a total of 240 and get the entire buff on the back end and keep adding on. But the numbers get a little tricky. You got to plot it out like this, is what I'm saying. It's very convenient to plot it out like this. And then if you really get tight on space after that, you can either go to unicast to expand it, or you just have to buy another controller once you get them up that many pixels. I'm not concerned about power in this particular case. This is just mapping it out where these elements are going to end up, and these points are going to end up in the connector map. Also, I've drawn in here where I'm going to hook these up into the groups. So there's actually 2 hookups per tree, because I had a left and a right, 150 each, and 150 is going to go to 4-1, 150 is going to go to 4-2, 150 to 3-1, 150 to 3-2, so those are my 2 trees, left and right. And then Universe 2-1 is where I'm going to put the circles. You might ask me why I go 4, 3, 2, 1, and that's because the way the card is set up, you have to power J19, which is on the right-hand side, to get the card to work at a minimum. That's in the instructions. And that powered side, that powers 3 and 4. So if I don't power anything on 1 and 2, it's kind of backwards. So I just go right to left, and I put my first stuff out on 4, and then go 3, 2, 1 in the groups on the controller. And when I'm talking about the groups on the controller, this is 4 over here. This group of 4 is number 4. These are the 3s, these are the 2s, and these are the 1s. Well, the power has to come in to the right to power the card, so I just went backwards, and that's just why I go 4, 3, 2, 1 and keep it in my mind. I don't want to jump around, because if I started at 3 and then went to 4 and then went back to 1 and then went to 2, it just starts to play in my head. So that's my advice as far as the timeline and the setup. So let's look at the 682 next. I've got it powered up here. I've got the Ethernet card. So again, this is position 2.1, and I've got a couple wires coming out. I got no power going into the card on this side. I'm going to power it independently. But I've got the data position that's going to head out to my circles and get connected there. And I've also got the ground position, and that's going to tie back to the amp that's driving it. And it's important to bring the commons back to the card, or at least tie them together when you're using more than one power supply. That cost me about 3 hours the other day. I just broke them out. I got it out here, and my MUN tree wasn't working, and I couldn't figure it out. It would light up. I tried swapping this. I tried swapping that. I was checking all my connections, because when these things go bad, like, you don't know if it's the connections, your wiring, the setup in the controller, the setup in Vixen, the power supplies themselves. There's all kinds of variables, and it's just really, you know how confusing it is. If you're stuck, you know exactly what I mean. And then ultimately I just figured out that, hey, no matter what power supply I used in the second tree, it wasn't working. Did a little aha moment as I was doing that. I was like, oh shoot. And so never tie the positives together. You always want to keep the positives independent, but the negatives all got to be tied back to the same clock with DC power supplying. So that's what happens on that one. This one is the 3 position, which happens to be the right tree or the second tree. And same type of thing. I got power and I got the ground, which is going to end up going straight to the power supply. And then the second one, 3.2 position, I just have the data out. And on 4, it's the same way. 4, I didn't need the ground because the ground came in. This power supply down here is my first power supply, which also powers the first tree. So I didn't need the ground here. The ground comes in down here. It's all shares a common ground, even though the voltage can be different on the 2 sides. So I just have 2 data lines coming out. So that's the setup on that portion of it. Power supplies are nothing too exciting. I mean, the ground, I got one going back to controller. This is the initial first power supply. It's a 40 ampere, 5 volt. Plenty of voltage because I think that I quoted these were 6 amps per 100. So 18 amps total. I would have here, I'm only using 40, so I'm not super stressing these switchable power supplies. Power goes out, and I've got a fuse in line, 30 amp fuse, so I really don't want to go over 30 amps, which is fine. I can only run 18 or whatever. This is another power supply. This is powering my hoops. I don't know about these styles. This one runs the fan when it's on all the time. Makes a lot of noise, so I'm not so happy. There's 2 different designs. I guess time will tell which of these are better. Initially, I like the bigger one that doesn't have any fan noise, and I got a 3rd one on this tree. So I got 3 power supplies. Again, never tie the positives together, but you have to tie the negatives together, or this controller is not going to work for you. Power-wise, I'm kind of flexible. This is where the power comes in, and all I've done is, paralleled it. It goes into the first, and then it goes into the leading edge. I put it in the first, the third, the fifth, and then the fifth will just come up and go down, and it just dangles on the end. So I've injected it on the front half of those 3 strings on the left-hand side, and the same thing, I tie it over, and then I do the front halves of the last 3. And this is all, again, once you get it set up, you have to start doing distances. You turn it on bright white. You see if you're losing. If I tried to just put power here and tried to go through 300 pixels, forget it. At 5 volts, it's going to start to drop. It starts to drop sometimes on the second half of the 50 even. So sometimes I need to inject both half, but I'll figure that out when I get out there. I'll figure out, it depends on total wire length and where you are and how far you're doing. So until you set it up there, I have some flexibility. I'm going to rewire a lot of this when I get out in the yard. I'm in the lab, I said, and when I get out to the yard, I'm going to rewire a lot of this, and I might need to inject at the other points. And all I'm going to do is tie parallel and keep going. I mean, I got plenty of amperage in the power supply. I just need to get it feeding amperage where it is to get a look that looks good. Here was the data string. The common string runs very similar. It just runs parallel and boom, 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 boom. The data string again runs in here, and then it's going to come out this side, and I've looped it, which is the data. This is the data string, so it just loops the next string, as I showed in the diagram. So pretty simple on the wiring side. Just got to understand what I'm trying to do there. All right, so I'm in the SAN devices. You hooked it up via your connection. You're connected to the card. Again, see my first video if you don't understand that, but I've gone to 192.168.x. In my case, it's 10.206, so card. And the first line is just my address. I'm on multicast. You want to make sure your test pattern is 0 or turned off. I know the default is not that. Nice to do test patterns sometimes, but for the most part. I've got universes 1 through 5, 6, 7. Those are your multicast, like I said, and unicast is out 8 through 12, so you can get those many extra universes. You can see I run it a little bit here. The data is only going 1 to 5. My output configuration, again, remembering my configuration today. So the bottom, number 4, is where I started. I'm using 2 outputs of the 2811 at 150 pixel lengths. So the left is 150, the right is 150. I'm using 2 outputs. Remember, I tied the left in and the right in to the data into 4.1 and 4.2. And the group size is 1. I don't know what that is. Red, green, blue is fine. I started at universe 1. I made it channel 1. Again, that's what I promised on my timeline. It's going to tell me I ended at universe 2 channel 390, which is what I predicted on the timeline if you go back to that. And I'm going to zigzag every 25. So that's how I get the zigzag reversed. I'm doing it in the controller here. And then, you come over and press update on the right. Let me zoom over a little bit just to get your refresh rates. I don't have any null pixels. You can null out some pixels if you wanted to put some pixels in length. And refresh rate is 82. I don't know if that's good or bad. You have to get out there and see how it visually looks. If it's not looking good, you can start to break out extra. I've got 150 pixels on one data string. This is a longer string than I had before. And if the refresh rate should be okay. But we'll see. If you can adjust it, and you have to rewire if you want to use 75 length pixels, for example, or whatever, something shorter. I'm kind of stuck. So output number 3 was my other tree. I've got it in group 3. I could have put it easily probably on 4.2 and 4. I could have made that, expanded that, but then the refresh rate is looking again. So, I've got the overhead. 3 is very identical. I'm only using 2 outputs. It's a 2811 again, 150 pixel length string. This is my other tree. And I'm starting on universe 3 and channel 1, and ends on 4 and 390 again, and I'm zigzagging every 75. Now when you zigzag in this manner, that entire group is going to zigzag from now on, so I really can't go connect the circles to either 3 or 4 because they'd be zigzagging, and so that screws the circles up. So the circles I had to go out and put on 2. I'm only using 1 output. Again, it's 2811 pixels. I'm using 136 string length, so the entire string of the 4 rings is one continuous string, red, green, blue. I'm starting at universe 5, channel 1. It tells me ends at 5408. Hopefully that's what my timeline math was. I'm not zigzagging this. So that's the setup on the stand devices for my setup. Hopefully that solved some of your problems if you ever got stuck there. If not, we'll go to the next section. The next screen is under System Configuration, and Setup Controller. So I'm setting up the controllers here. I've got my E1.31 streaming. In this case, I put 5,000 channels, which is more than handles that 3,500 total. You can put an artificially high number. It doesn't really matter here. I'm going to go down to Configure Controller. And so here's where again, this is another point where you get stuck. But I've got Universe 1, starting at 1, going for 510. It's on my LAN 2. And also I got the check mark, make sure it's active, I guess, ACT, I don't know what that is, but probably active because I can unactivate it and the lights won't light up. And then I'm also using Universe 2, starting at 511, again, remember the timeline, and 510 in size. So 1 and 2, I got to have both those activated, otherwise half the tree doesn't work, or not half, X% of the tree, 390 pixels, or 390 data points don't work. 3 and 4 are set up the same way. 3 starts at 1021, it's 510 long. 4 starts at 1531 and it's 510 long. So 3 and 4, remember, are going towards the other tree, the second tree, and timeline again. So I got to have those turned on. And lastly, I start at Universe 5, and I'm starting at 2041. So again, this is absolute position, 510. If you put 1s all in here, 1, 1, 1, 1, 1, which is the default, you will not work. So again, that's how I keep things absolute, keep them in order, and then just turn them all on. Good to go. All right, make sure you push OK when you're done here. Otherwise, I think it doesn't save. If you just do the X in the corner, it doesn't save the settings. Certainly when you do the patch elements, it's very much like that. And that'll also confuse you. You think you're changing it, and you go back in, and it's reset back to the original. It's because you didn't press the OK down in the corner. And last but not least, system configuration and setup display. This is where you get all your patch points. Should be pretty straightforward. You come over here, I've got my tree. I've actually got my tree broken into 12. Let me expand it. 12 strings, and each string has 25. But when you're setting this up, all you do is hit tree, and then make sure it's not dimming curve. Make sure it's color handling, and do the configuration, and make it all patched, all colors. The bottom thing, so you get 900. Even though the tree has 300, you're gonna have 900 total patch points. Hopefully that's in focus. 900 total patch points. I've got connected 900 already, but you're going to select the 900 here, and all you need to go do is go over to streaming, expand the streaming over here on the right hand side, and do 1 through 900, and then patch them down here. And then the second tree, you're going to do the same thing. Make sure you got 900 available, go over the right side. This time start at 1021 and select 900 of them, and then patch them. And then each one of these circles were, let's see, 34 times 3, I think that's 102. Help my math there, math in public. So yeah, 102 patch points, and then I'm going to select whatever Universe 5 was. I don't remember exactly what that was, but go back to the timeline. So you're going to patch 102, and then the 102 right after that, 102 right after that, or you can select all of them and do 408 points. So that's the patching you have to do. Again, very similar. Make sure that the OK button is pressed down here. Otherwise it won't take, and when you go back and double check it. So again, the timeline comes in very helpful there, and I can't overemphasize, if you get any of that wrong, then you could be patching to points that don't light. So this is another reason why you don't light. It doesn't tell you it's wrong, but that's the explanation of how you would patch. You need to patch your trees to the absolute. If you need to do zigzag there, that's a completely different story. You would go in and select one string, do the reversal. There's a reversal button, and pick the 1 through 25, and then the next string 26 through 50, and reverse that one. Now, the first one you wouldn't reverse, but the second one you would reverse, because that gets your tree, and you'd have to do that manually. But again, if you're really tight on space, maybe you buy another card, or you just, it's much easier to program the way that I just did it there, which is just take the whole tree, drop it into 900 and consecutive, and it just links right up. So last but not least, I just opened a sequence here, and I know these show it at some points. I've done, under these circles, I've done some other patterns later on. This is a high level setup. If you expand them, like some of this circle 1, you can see out here that I've got only circle the top half of the circle. I got a circle top and a circle bottom, circle number 1 top and circle. I talked about that with 17 pixels apiece. So it doesn't always show up. It shows up here. So let me just F5, fire it up, stop it when I'm in this color, and you can see I've got nice bright red, and the circles, I all gave different colors to the circle. The first one's kind of purplish, blue, white, and then green. So they're all lit up, they're all working. It's what I'm looking for. That's kind of a test pattern for me. Ultimately, I'll go in and do the whites, but you want to make sure you got the first and the last. You got your pixels all set up right, and then we'll just kind of fire through here. You can tell if you do a little, you see how that was popping up. When your zigzag's wrong, the first one will be going up and the second one will be going down, and so that's how you can tell you got the zigzag right and wrong. And I got just some effects going on here, and the lights are kind of going around here. So that's what it's going to look like. So hopefully this was a little bit helpful to you. Again, not terribly exciting, but if you're stuck somewhere, hopefully this video really helped you out. That's what I'm trying to get to. I'll probably do another video when I'm out of the lab here into the yard, get it typed up, see if I can. I really got to work on some programming and stuff like that. But you see what I'm trying, these loops, but that's what you got to play with now. I got to do music videos. So if you have any questions after this, go ahead and post them below, or go back and refer to my first video, which is, I know this video ended up being long too. There's just a lot of info to compress, but hopefully that helped you out between the two videos. And of course, when you start going to, this is only a 700 something pixel display. I'm not the master of multiple SanDisk devices, but that's some of my hints to getting just one with multiple power supplies and quite a number of pixels. I still have some growth left here, but probably not going to happen this year. But that's what it's go for. So good luck. Thanks for watching, and I'll check in with you later.